everyone. With this video I'm gonna show some Wireshark basic protocol analysis. To do this we are going to select capture options once we open our Wireshark. Basically you of course want to select the active connection, the active connection, the active interface. I'm gonna select Wi-Fi one, and here you can select to stop capture automatically after a number of packets or something like this, but right now I'm not gonna do that. I'm just gonna select start, and right now I'm capturing packets. As you can see, I already captured some TCP packets and such. These are basically generated by some background process and stuff like that. As you can see, it is beginning to populate and stuff. So what I'm gonna do right now is focus on HTTP requests, and let's see how it goes. Here, for example, you can see some Microsoft HTTP. So basically this is some Windows process, but let's see how it works exactly. So the first protocol I'm gonna analyze is HTTP, but I'm gonna make an HTTP request with my browser. So for example, if I go on Wikipedia, so and Wikipedia, and select this, here is Wikipedia. Let's see how what happened here. So basically I can stop getting packets for a while because I do not need them, and let's see how can this work. So let's see, the first packet I'm gonna analyze here, these are still from Microsoft. As you can see, destination is are very different, and here is the one that I am going to analyze first. This is the HTTP GET requests for the Wikipedia website. So let's analyze this. We can see that we have different layers. This guy here, Hypertext Transfer Protocol, is the application level. This guy here, TCP, is the transport level. This is the network level or layer, and this is the data link layer. And then we have of course the physical layer, but it's not shown here. Now what we're gonna do is practically analyze every layer one by one. The data link layer is just gonna show us the MAC address for our destination and our source. Of course, this is gonna be my Wi-Fi adapter and my router, which are both Netgears. Now, what we're gonna do here is analyze the Internet Protocol version 4. Why version 4? Because we have IPv6 as well, but it's not yet implemented into the internet. So let's see. The version is 4 because, as I've said, it might be 6, but this of course is 4 because it says so. The header length is 20 bytes, so it's pretty standard. The total length is 402, and it's a don't fragment. What does it mean? It means that basically we have MTU, which is a maximum transmission unit, which is bigger than the total length of the packet, so it's not needed to fragment this thing. And of course the fragment offset is 0. This is pretty much the information about fragmentation. The source is my IP 199.168.0.5, and destination is a Wikipedia website. The website is the IP is how do I get this? With a DNS protocol, which we will see afterwards. Now let's see TCP. the source port is the browser, the port that my browser is using. It's 5181.7, and the destination port is 80. Of course, what happens here is that basically an HTTP URL, Universal Resource Locator, is something like this: HTTP. Then we have the port that is usually here, but of course you won't see it because the 80 is the standard and default port. And as a matter of fact, if I just click it again, it will redirect me here. Now, let's analyze the GET request, the application layer. Alright, so as we may recall, HTTP 1.1 creates a persistent connection to the website. What happens here? We are requesting the path slash on the website wikipedia.org. Alright, so what happens here is that we have a response, and the response we get in the following packet. Let's say, let me just analyze this for a second. We have host wikipedia.org, connection keep alive, accept text HTML, application HTML, XML, application image, and such. The user agent is pretty much basically telling what browser we are at, and you can see Chrome and the version of Chrome, and the accept language is of course pretty self-explanatory. Now we want to analyze the HTTP response for this guy. Alright, so let's see what happens. The first thing I'm gonna do is check if it fragmented, and it doesn't really look so. You can see do not fragment, and I'm gonna check the HTTP response, which is 301 moved permanently. So what happened here is the following. When I went to Wikipedia, I select Wikipedia, and it redirected me to /wiki/main page. So basically what happened here is that I had a redirection of my made by the browser. Why did I redirect? And the response is of course our answer. It's saying, alright, this guy here is not here anymore, so you might want to look elsewhere. I'm gonna show you where, and this is the location where it's being redirected, and wikipedia.org wiki main page. And of course this is basically what happened here. Now let's see though that our browser automatically generated another get for /wiki/main page, and it looks pretty similar to our first get, but now we have get /wiki/main page and not /getWiki as we did before. As you can see, here we had slash and nothing, get slash. Here we have get /wiki/main page. And now let's see the response. Now the response is 200 okay, and this is awesome because this is what we were looking for. The 200 status code is pretty much the best we can hope for, and this is the content length. It's actually way bigger than the first one, if you can recall. And let's see what we have here. We have the HTML for the page. Now you will see just a bunch of text, and someone familiar with HTML might understand this text, but basically this text is being converted from our browser into this page. So this page is nothing but the translation of this code, this HTML code, which was passed by this HTTP response generated after we request a page from the get of /wiki/main page, which was a redirection of get/HTTP 1.1. So just to make sure you understood what happened here, I'm gonna say it again. I requested a page with the get method with HTTP 1.1, which generates a persistent connection to the page. I was answered by the server with a 301 source code moved permanently, and my browser generated a get response with /wiki/main page HTTP 1.1 response. Then what happened here is that finally I get the response I'm looking for with the 200 OK code. Now what are these? Basically are all the images, all the pictures and such that I'm getting. Right, so the funny thing is, if this was HTTP 1.0, we would have so many HTTP connections opened, because HTTP 1.0 was not actually persistent, while HTTP 1.1 is. And of course you will see a lot of 200 OK PNG, 200 OK JPEG. These are all the images that are getting transferred to my browser. And this is pretty much the Wireshark analysis for HTTP protocol. Thanks for watching.